just to get it out of the way, I know I look pretty bad with these short pants because there's some whole debacle that included me, like a very forgetful aunt and me losing all my clothes. So it's either this or nothing. So, let's get started. My internship was at Academia Sinica, the Institute of Information Technology. My co-intern was Russell Wan, and we both worked on MAD also. Stands for Mobile Assistant for Disasters. And I want to introduce the Open ISDM MAD team at Academia Sinica. There's my supervisor, Professor Jane Liu, and my TPT supervisor, collaborator, Johnson Su, and Andrew Lai, Russell Wan, and Gentry Yao. So I'm going to go into more detail into MAD. So basically, what is MAD? MAD is a mobile application designed to enable the general public to easily retrieve and store in their mobile phones disaster preparedness information and response information from available information sources, and thus improve their personal safety when disastrous events occur. So why did we create this app? For the sake of motivation, let's consider this scenario. Suppose a strong typhoon hits Taipei.
Ooh, I'm a typhoon.
And one of you guys, as foreign interns, is spending a day in the city. Transportation systems are down, and internet and phone connections are no longer reliable. But fortunately, your IE or Izan told you to install MAD. With this app, you can now search for shelters and download information on locations of schools designated as public shelters, parks with portable water, and emergency medical care centers, sorted by distance from your current location. More importantly, MAD uses offline street map, so no internet connection is required for you to navigate around the city. So MAD has a client-server structure, which involves a system of servers that are responsible for the discovery and retrieval of useful shelter data in disaster response areas around the user's location. The shelter data starts in linked open data or open data sources, for example, Taipei open data, and that information goes to the interface server, which is a standalone and very powerful server that serves as an administrator, data collector, and an information repository. From there, the information goes to POS servers, which are simple and ultra lightweight servers that are ideal for strategic deployment at points of services such as convenience stores, such as 7-Elevens, Family Mart, schools, or hospitals. They act as data distribution points and can provide nearby users with important shelter data, not only through internet connection, but local Wi-Fi connection also. The reason for this is so that the users of MAD can still obtain information even if the internet connection were to drop due to a natural disaster. So other functions of MAD. Currently, the MAD team is still in development of a POS function for the MAD application, which would basically enable your mobile phone to become a mobile POS server. So if nearby users aren't near a static POS server, your phone could also send out useful shelter information to other nearby users, thus increasing our reach of information. Another function that we just now started working on is an emergency board function. This would be useful, for example, if you saw a tree fall down on Hebing Donglu, you could tell nearby users to avoid this street at all costs, so they could be more prepared. And one of my ideas that I suggested to my boss was my idea is for the static POS servers to also project not only the shelter data, but something called an APK file, which is an Android install file. That's all you need to install in order for your Android phone to install an app. And this would be useful because if there's no internet connection, users without MAD, they would sort of be lost. So this would allow users to also obtain MAD even if there's no internet connection. And once we get this working, theoretically, your POS mobile phone could then also send out the APK file, which would create sort of like an ad hoc system or kind of like a chain reaction. And the OpenISDM team has already implemented this app on iOS, and my work consisted of developing the user interface for this app on Android. And to do that, I had to spend about the first 3 weeks learning XML, which is for the visual aspect of the program. And I also had to strengthen my Java skills for the functional aspect of the program. And I made it all in the Android Developer Tools version of Clips. And I was going to actually demo my app, but the program didn't work on this computer, so I just have boring screenshots. But this is the main map screen. On this screen, you would be able to navigate from your current location to whatever shelter you would want to go to. And there's also the list view button up there, which would display it in lists, and it would just tell you which one is closest to you. This is the screen where you would see Wi-Fi hotspots where you could download additional information, but I didn't do the Java yet that would populate this list. And this is the screen where you click that button and you would host your phone as a mobile hotspot to project the APK or the shelter data. And this is the screen for the emergency board. Now I'll pass it off to my co-intern Philip.
Hi, I'm Philip Lin, and how I'm introduced to OpenISD as a virtual repository. Now, how this relates to Matt is that, what Vincent does is more of the top-end work. I do the back-end work where I would provide the linked open data to populate his interface server. Okay, so the purpose of the virtual repository is the transition from unlinked to linked open data via a format called RDF, Resource Description Format Framework. Now, this RDF contains one object, subject, predicate, object. And why we need this is that, for example, if I have, natural disaster is a typhoon. Now, the subject will be natural disaster, predicate is, and then typhoon, and we'll link these two terms. So natural disaster will be related to typhoon. And why this matters, for example, if I'm searching for natural disaster, how can I know what a natural disaster is? You have to put natural disaster in terms of typhoon, earthquake, volcano eruption, these types of words. And then therefore we can have more effective search. Now, what is the virtual repository? And it's pretty much this. It's divided into 3 parts: the URI management service, URI search service, and RDF translator. Click. Now, I want you to think about it like this. One more click. The URI management service contains a database of all these links, as I said, unlinked to linked data. And then, this database has many functions such as adding and then searching for new links. Now, if I wanted to say add a new link, first I would search my database to see if I have it already. If I have it already, then of course I don't need that. But if I need to go to other sources to search for it, I would have to use the URI search service, which is what I do. The RDF translator, how this works is that in order to transition from unlinked to linked, I'll need to convert a format such as XML to this RDF, which has the SPO triple. Now this is my work, the URI search service. Now, the URI search service has 3 major components: the Sparkle query, sending to endpoint, and receiving results. Now, to make this a little bit more easy to understand, I'll draw an analogy to another search thing, such as Google. You would input something such as Taiwan tourist attractions, and then you would send it to an endpoint, such as Google, Yahoo, or any other search engine, and then you'll receive the results. Now, these 3 steps are a little bit more complicated than that. So, next slide. Now, the Sparkle query looks like this. This will be your input to, and then how this relates is that I want to find a subject, predicate, object that matches these conditions. Next slide. Now, how this put this in full-time, how this works. So I would go to an endpoint such as dvpedia.org. I would input the query text, and I would receive my result. And with this result, I can therefore make the links that I need, and then store them into my database, which is the URI management service. Now, what I've done is that I implemented this, not using Mozilla Firefox, Google Chrome, like I made a program that did this sort of thing. So, for example, if I were to have an input such as Typhoon, I would make my Sprockle query, and then I'll send it to an endpoint such as DBpedia, and I would get my result. This is like the HTML source code, and then I want the link, because I want to link the word Typhoon to this resource right here. Now for like more practical use, like if I wanted to upload it to the web, then I'll need to use a language such as HTML. And then this is the HTML implementation that I wrote, which is a little bit more simpler, a little bit more basic, but it gets the job done. Where I'll input Typhoons, send to endpoints, and then get my results. And then as for final, like I think during this TTT internship, like I learned a lot. I learned about HTML, Python, a little more technical aspects. More importantly, I learned how great Taiwan is.
Me too. I learned XML, but more importantly, I got more in touch with my Taiwanese roots, and I made so many friends here that I want to stay friends with just for the rest of my life.
I'll always say this to you, Vincent. I really enjoyed working with you. If you have any questions for me or Vincent, virtual repository, or any more questions on math?
Or you want to be my friend? Yeah, questions? Thank you.
Any questions? Yeah, okay. Thank you, Vincent and Philip.